Hello class, this is Mr. Lehman. This is part 4 of our remediation summary here. Alright, so we're going to take a look at the very last page, the back of the last page, part 7 and part 8. Part 7 and part 8. So in part 7, we're going to do a new type of calculation where we go from number of moles to grams. So if you know how many moles of something you have, how many grams of that substance do you need? Alright, so once again, we're using that same triangle as we used for the last section. So mass is equal to moles times the molar mass. So we're solving for mass. We cover that up. The mass in grams is equal to the number of moles times how much each mole weighs. And we find that out by using the periodic table. Alright, so that's our equation. Let's go ahead and get into this here. 14, question 14. We have 1.5 moles of gold metal in a statue. How much would that weigh? How much would that gold weigh? Well, how much does a mole weigh? A mole weighs 196.97 grams. So you multiply how many moles we have by how much each mole weighs, then we get 295.46 grams of gold. I'm sorry about the announcements going on right now. I'm going to keep going. So there's our answer to 14. Let's go to 15. To solve for 15, 50 aluminum soda cans contain 25 moles of aluminum. How many grams of aluminum would these 25 moles weigh? So 25 moles of aluminum times how much each mole weighs. Look at the periodic table. A mole of aluminum weighs 26.98 grams. 25 moles times 26.98 grams. 674 and a half grams of aluminum. It's pretty easy, right? You just take how many moles you have times how much each mole weighs. Now I tell you how many grams of something you have. So don't overthink that question. Part 8, last part. We have a second triangle. This triangle says that if you know how many moles you have, we know how many atoms are in a mole, or molecules in a mole. Avogadro's number. This times this is going to tell you how many atoms are in that sample. So number of moles times how many atoms are in a mole will tell you how many atoms are in a sample. That makes perfect sense, right? Alright, so let's take a look at 16 and 17 using that formula. 16, if you have a ring that has 0.06 moles of gold, how many atoms of gold are there? That's how many moles we have. If we times it by how many atoms are in a mole, and we get it is 3.61 times 10 to the 22nd atoms of gold. That makes sense. We have less than Avogadro's number because we have less than a mole. It's just like there's 12 in a dozen. If you have less than a dozen, you have less than 12 eggs. So if you got a number that was bigger than Avogadro's number, you know you did something wrong. One more to go. We're almost done here. Question 17. Question 17. We have 5 moles of helium in a balloon. How many atoms of helium do we have in our balloon? We know how many moles we have. We know how many atoms are in a mole. Calculate this. 5 times 6.02 times 10 to the 23rd is 3.01 times 10 to the 24th atoms. We know that if we have 5 moles, we have 5 times the number, Avogadro's number. So if you got a number that was smaller than Avogadro's number, that doesn't make any sense at all because we have more than a mole. So if you had 5 dozen eggs, we would have more than 12 eggs. We would have 60 eggs. So if you have 5 dozen eggs and you say you have 3 eggs, that doesn't make any sense. Just like if you have less than Avogadro's number, but you have more than a mole, that doesn't make any sense. So make sure you use those triangles, know how to use those triangles, and you can figure out any calculation that I throw at you. So I hope these tutorials helped you. Get ready for that test. Test is coming up Wednesday.